When you start with cloud networking, basically you're going to have your hypervisors and then your tunnel net. We have the ability to use cloud networks inside of Rackspace, or our cells in the data centers for cloud. What it does is it encapsulates the packet from the VM and then will send it to the hypervisor for whatever VM you're sending it to. When we do Rack Connect, what we're doing is we do basically the same thing, except we send it over to this gateway service pair. Instead of using an overlay, a virtual overlay network, like we have on the cloud, we're going to convert it to an Ethernet packet. And the difference between a regular virtual overlay packet and one that's going to go over to the dedicated side for going to your dedicated equipment is this one has a little VLAN tag right here. It only has a VLAN tag when it's going to the dedicated side so that it can be identified for which account. Once it hits the gateway service pairs, it's turned into an Ethernet packet, and then it's transferred over to our bridging service. What this does is it's basically just bridging our different VLAN aggregation zones, and it basically knows that customer that's coming from the cloud that's on interface 3 or 4, which is our cloud side, that's on VLAN 20, matches VLAN 500 in this zone. So it goes and it takes the VLAN over here, switches it over, puts it over there, and gives it the correct VLAN tag, so it gets put into your environment. Then it's going to come into the zone and get routed through there to whatever your network connected device is, which in the case of my demo today will be a big IP F5, which can then be used, it can be sent out to the internet through a VIP, so you can load balance your cloud servers with dedicated gear, or it can be sent to your dedicated database server inside of the network, and then everything's behind a dedicated firewall. And that's how cloud networks becomes just another dedicated network. In order to do what I'm doing, what I want to do is we want to use the cloud autoscale feature, where you can use the Rackspace Monitoring to hit webhooks in order to scale up and scale down your infrastructure based on whatever metric you want to measure from the server. The one I chose was to measure traffic in and traffic out, and when it got over a certain amount, to make more servers. So to spin up a server from the cloud and to get it to be automatically bootstrapped, this is the CloudNet file I used. All it does is it hits this webhook on my master, and it passes the host name and instance ID. And then once it does that, it's going to come in here. This is the auto-scaling webhook. It's the same one you'll find essentially on the Salt formulas. I think it's called Salt Cloud Reactor. All it does is it takes in all the post data, and it checks any extra information you want to set for that device, which in this case I set the Rack Connect v3 cloud network, so it knows which IP to go in. I can show you that in a minute during the demo. And then it's going to set the host name in the VM instances, and then set the ID, and then strip out all extra variables, all your dunder pub, dunder, all the extra stuff that you don't actually need. That's all stuff in the formula as well. And then it just returns basically the runner state. The next one is how we delete servers. What I want to do is I don't want to just delete a server. It also needs to be deleted from the autoscale group. So what this does is it comes in for the monitoring events. Instead of just deleting them, I want to delete the key, and I want to possibly have it replace a server. If there's another monitoring event, like a website doesn't display on one server when it does a health check, I want it to just delete that server and make a new one. So by default, it passes replace equals true. And if it fails like an HTTP check, it'll just delete it and make a new one. Instead of, if it fails the networking check, I want it to make more. So what I'm doing here is basically regular authentication, and then down here, make a cloud client, and then we find the group, and then just the API call right here for the autoscale group to build another server. And then if it's deleting it, it is deleting it. So if it is actually deleting it, it will delete the key as well. The next one, I believe, is how I actually set up monitoring. All the stuff that's in this one is part of the reason that we started with the Pyrex cloud driver. This will all be eventually included when I get around to writing it, but the goal is to have a runner or even at the end point, a cloud action, or that could be used to set up monitoring on a cloud server. It's just doing a regular payload. It makes the entity, or it makes the check down here. And then we're going to make a call to make the check to the entity. And then this is what our check is. It's going to check if the transfer bytes is greater than 5, I think that's 5 megabytes. I picked an arbitrarily small number just so that I could do a quick demo. And then over here, the next one is network going out, or network received. And then we're just setting those there. The last one is, these are all I'm doing is I have 4 simple webhooks that go to all of those states. And that's pretty much all I have set up for slides, just kind of showing what I'm about to show. One of my coworkers wrote a tool called Load, I forget what it's called. It's called Load Tester. It uses Siege or Apache Benchmark. And we're going to hit this website, which is an extra set of my blog that I set up. Hold on. This one. I have the states spin up the default states for this one, put a 40 megabyte image on each one of them. It'll find this right here. Simulate. We'll do 50. Max delay between requests 10. Run benchmark for 10 minutes. And we'll do all 8 of the load servers I have. And we'll submit a query. And what we'll see in just a second is servers. This is the monitoring check I set up. So you should, in a minute, start seeing this button turn red. It takes like a minute. There's this initial spike. There, now it's red. We should, if we go back to servers, it's creating 3 new servers. And so each of them has, each of them has 2 monitoring checks on each of them. So at max, they can each spin up 2 more servers. It causes some problems on the way back when it starts to come back down at the end of something. And what it'll do is there's also a cron job in the autoscale that just scales down 1 server every 10 minutes to make sure that if everything goes smoothly, I have tested it and seen everything come all the way back down. But it doesn't always happen. So I have a cron job that just makes sure everything comes down. And it takes about a little over a minute and a half for these ones to be all completely up and have their monitoring check set. And then they'll spin up 2 more servers until the test ends, and then it'll start coming back down. Here it's been created. We should be able to see on the master also these events. These ones are now authing. And then we'll see another event like this one right here. Where is it? It's deploying the script through the cloud create runner. There's another server being bootstrapped. Here's the other thing. They have, in order to be put into the dedicated load balancer, there's a metadata that gets put onto the server, and when it comes up, it automatically gets put. All of our dedicated load balancers inside of RackConnect v3 are assigned a UUID. Once you put it in there, it'll auto scale, and it'll automatically get put into the VIP for that load balancer. After that, I have 2 health checks on the dedicated side. One's for checking if it's enabled.html exists, and the first state of any high state is to make sure that file doesn't exist, and then the last state is to make sure it does exist. So as soon as the high state's done running, it'll re-enable the server and the load balancer. Let's see if it's... Then it has, this one has its monitoring checks up. No data yet. There. There we go. And what will eventually happen is, depending on how long it goes, eventually they should all end up in yellow state and warning. If they're all in the warning state, nothing happens. When they go back to OK state, they send the monitoring, our monitoring, sends an event to my Salt master that waits for 3 minutes and then sends an event to delete the server. The 3 minutes is there in case it needs to scale back into critical and make more servers before it gets deleted, but it deletes itself. And the reason I do it on the Salt master is because sending a webhook to auto-scale the auto-scale down, unfortunately doesn't delete just that one server. It deletes any of the servers. But yeah, I also wanted to do the wait, so it kind of worked out. But yeah, so slowly what you'll see is, though, I don't know that the test is long enough. It usually takes about 20 minutes for it to run in order for it to hit that point where all of them are yellow, and then it just stops scaling until the test ends, and then they all start going into green, and they'll all start deleting. Now, they all send their event, and then it waits, but the API will only delete all the way down to the minimum number of servers, which is 3. So it'll never go below that. Let's see if it has more. So then one of the nice things about this is the health checks can be set on anything. You can set it to monitor your CPU, you can set it to monitor your networking, you can set it to monitor your load. Anything that you can physically test on the server, you can set it to monitor if MySQL's running. MySQL's not running, kill it, make a new one. The point of all that is to treat them like cattle, so that anytime one of the servers just doesn't work, Salt provisions a new one and then deletes the old one. I tell too many people that and no one does it. But it doesn't have a lot of load, but it should be all of them are up. You can also see that it's rotating. And there's the name of all of them. I think someone turned on the sticky sessions. The other thing to note about these servers is they don't have a public IP address. They only have our ServiceNet IP and then the IP inside of Rack Connect. You can provision one if you want, but it doesn't by default. And you also see here that it's in that pool. Any questions while this runs?
How long did this take you all together to set up and troubleshoot?
About a week. And it's still not perfect, as you can see. Like some of the monitoring stuff takes a little while. One of the big ones is the thing that I would probably spend the most time on is you have to tweak exactly what you're testing to figure out what you need to alert on. Oh, the question was, how long did this take you to set up? Let's see, now they're all starting to kind of go into warning because there's enough servers up. And then it'll stop scaling. And then when this finishes running, which is now actually, that'll start to go back into OK status. And we'll start to see events here. Those are still servers coming up. This is the reactor event that sets up monitoring.
For your monitoring, have you thought about the new beacons system, or would you still want to use the Rackspace monitoring?
The question was if I had thought about using the new beacons or if I would still use the Rackspace monitoring. It would be perfect for beacons because one of the problems with the Rackspace monitoring is it only alerts when it goes into critical the first time. It doesn't continue hitting the auto scale. And then there's some inconsistencies where it ends up here where it has two monitoring entities on it, and I'm sure one of these two, I don't know why those two have two of them now. Should start seeing delete events coming through. Too much. right here, you'll see this is one of the delete events that comes through. It'll get passed off, and it's just waiting the time limit before it actually deletes the server. Should be 3 minutes. There they go. Is that them? Yep, there they go. You'll see the wheel.delete is there. You should start seeing some of these disappear. Yep, down to 7. What do you got?
So you said it keeps up 3 at all times. Are there 3 specific ones it keeps up at all times, or is it random?
No, it picks a random 3. It'll do whatever the last 3 to alert were.
Repeat the question.
Does it keep up a specific 3, or is it any random 3? And it just picks up whatever the last 3 to go back into OK status, or the last ones to try to delete themselves are the 3 that stay. There's one more delete coming through. It's probably going to be stuck with 4, but then in 10 minutes it'll delete one more from the cron job. I think that's it. Are there any other questions? Eventually, a lot of this stuff, specifically the monitoring stuff, is going to go into the Pyrex module, just because it's already in the Pyrex library, and then it'll be available through, or the Pyrex cloud driver. Then it'll be available through the regular cloud action stuff. Specifically, like which one? Specifically, like the Pyrex queues is written, where all it's using is the cloud action. Right here, it's just doing a cloud action, and then a queues exist, and then that literally runs through this Pyrex one that has queue exists, queue show, queue create, and queue delete. That's calling to the Pyrex library. Is up here. Am I down? Nope, still at 5. I don't know. I think that's as low as it's going to go for right now. There's no more questions. I don't have anything else. Run the cron job? I can't trigger the cron job. The cron job's actually through the auto scale event. So it has 2 setups, and unfortunately I can't show them because using the RackConnect v3 thing in auto scale causes the display to break. But if it was, there would be 3 right here. One is for spinning up, one's for spinning down, and then there's one more that's a cron that just spins down one server every 10 minutes until it reaches the minimum. Oh, now it's down to 4. Yeah.
You submitted that as something fixed?
Yep. He asked if I had submitted that as something to fix. Yes, I've brought it to the attention of the portal team. All right, I think that's it. That is my